Okay, Bridge 1 students, today we're going to talk about the perpendicular bisector theorem, and we're going to apply it too. But first, let's construct a perpendicular bisector. If you have a compass at home, I'd encourage you to do this yourself. So we have constructed a perpendicular bisector, meaning that this line, I'll call it line L, that I've just constructed is perpendicular to segment AB and bisects it. In other words, we'll call this C. Segment AC is congruent to segment BC. Now let's look at actually what's called the perpendicular bisector theorem, which says that you take any point in a perpendicular bisector. This one's nice because we're going to construct a perfect equilateral triangle, but we can take any point on that perpendicular bisector. And the line connecting the endpoints of the segment to that point on the perpendicular bisector, those two segments will be the same. I didn't say that quite perfectly mathematically, but you can see it visually. So for instance here, I'll call this point D. So AD is going to be congruent to BD. And for that matter, ABCD, we'll call this point E. AE is congruent to DE. Or for that matter, we could pick a point out here, or further down on the line too, below the origin. Maybe you can hear my dog in the background. This point as well, these points, this segment here is congruent to this segment over here. Call this one F. AF congruent to BF. Anyhow, you get the idea. That is the elegant and beautiful perpendicular bisector theorem, and we're going to do a really interesting application of this in the next video.